All right. So let's do just a little bit of review on what we learned last time. Uh, First of all, we learned triangles. Now, what do you remember about triangles? Say, for example, if you have a triangle, and of course, we got three angles. If we add all three angles together, what will we have? So we got angle A plus angle B, yeah, plus angle C is 180. And that doesn't matter what kind of triangles we're dealing with. And we also have something called isosceles triangle. Now, for isosceles triangle, the definition is that the two sides are the same. But what happened to the angle here? Those we call the base angles. Yeah, what's the relationship of those two base angles? Let's say this is again ABC. What's the relationship? Yeah, they will be the same. And how about equilateral triangle? What is the internal angle? So equilateral triangle, of course, we got three sides are exactly the same length. Perfect. Good job. All right. Then we talk about parallel lines. Parallel lines. And on the parallel lines, we have its properties. So if, let's see, this angle and that angle, what do we call them? No, no. We know those two angles are congruent, but those two angles are called, first of all, they are interior angles. Mhm. And but they are on either side of the transverse. So is this line. So that's called alternate interior angles. And we know that if the two lines are parallel, then those two angles are congruent. Okay. Now, how about what's the name for, let's call this angle and that angle? What do we call them? No, those two angles are still interior because it's inside the two lines. This is how we know the angles. Any angle inside the two lines are interior. So these two red angles are interior, but they're on the same side of the transverse. So their name is called consecutive because one after another, consecutive interior angles. And what is a property here? If the two lines are um, parallel, what happened to what's the relationship of those two consecutive interior angles? Okay, so those two angles add together should have 180, which means those two angles are supplementary. Good?
The two red ones.
Yeah, the two elements. Okay, so now we're going to looking at, if we call this green, this is green. What do we call those two green angles?
Sorry, it's glitching. What'd you say?
Yeah, if we're those two green angles, one is inside, which is interior, one is outside, which is exterior. What do we call them? Yeah, the top one's interior, but we have these two together. What do we call them? What's their relationship? Yeah, when we're doing parallel lines, we're talking about a pair of angles. So they have a relationship. That's why we give them specific names. So those two green, one is inside, one is outside, but on the same side of the uh, transversal. No, consecutive already did. That's the red one. That's consecutive interior. So they are
Oh,
not consecutive, but the one is inside, one is outside. This is called corresponding angles. Corresponding angles. Good. Are we good? Okay. Corresponding angles. What relationship do they have if those two lines are parallel?
sorry. What's the question?
Yeah. If the two lines are parallel, what relationship is the corresponding angles? So basically, they are. We're asking: are they congruent or are they supplementary?
Supplementary.
No, actually, they are congruent. Good.
Hmm.
So now, how do we remember those kind of things? Actually, all we need to remember is this: the alternate interior angles are congruent. Good.
Good.
So then now we can see uh, we gave a name to them. Let's call this one is angle one, angle two, angle three, angle four, and it's called angle five. Okay. Well, if so, basically we know that angle one is congruent to angle three. Now, if that's the case, we can see that angle one and angle two, that's 180 because on the same line. Well, because angle one is also equal to angle two, congruent. So angle three plus angle two is 180. So that gives us this theorem. Good. Now you can also see that angle five, what's the relationship between angle one and angle five? So basically we're saying two lines intersect. There is angle here, is angle here. What's the name of those two angles?
They would be the same.
Right. This is called vertical angles. So vertical angles are congruent. So angle 1 is congruent to angle 5. So therefore, because angle 1 is also congruent to angle 3, so angle 3 is also congruent to angle 5, which is our third theorem. Good. And so you can see that from our first theorem, we basically can
Yes.
can deduce the second. Then from that, also from the first one, we can get our third one. Good. So that means we all need to remember is about alternate interior angles. So if alternate interior angles are congruent, then we can work out the other two theorems. Actually, there's more on that. But once you know those two, the rest we can derive. Good. Okay. So now we're going to, today's lesson is about the quadrilateral. Now, from the name, we got actually two parts. One is quad. Now we know quad is four. So quadrilateral. Lateral means the side. So quadrilateral is any shape we have four sides. So this is quadrilateral, or we could have something strange like that. That's also quadrilateral because we got four sides, four straight line. You could also have something like this. That is also quadrilateral because we got four sides. Good. So that's the definition of quadrilateral. So basically, the simple definition is that it has four sides, and also it has four vertices. So each one is a vertex. The plural is called vertices. So four sides, four vertices, and of course we got four internal angles. So when we did triangle, we said there are three angles. You can also call triangle as trilateral, three sides. But when we're talking about quadrilaterals, we're just basically using quadrilateral instead of using quadrangular. I mean, you can still call that quadrangular, but the normal name is just quadrilateral. So we have those kind. This anything as long as we have made of four straight lines and they are closed, then that's quadrilateral. Now this is not quadrilateral because they are not closed. We got four sides, 1, 2, 3, 4, but they are not closed. So that's not. Has to be closed and has to have four sides. Okay. And quadrilaterals also have this property that is they have two diagonals. One is from here to here. One is from here to here. It's called diagonals. You could have here to here and here to here. And this one, same thing. You could have from here to here is one, and from here to here is another. So they also have two diagonals. Good. Okay, given that we're looking at some specific quadrilaterals, the first one is we called parallelogram. So what is parallelogram in your words?
Isn't it a shape where it's like both sides are the same, where they could be split in half and it's mirrored?
Very good. So the definition is that we got these two sides are parallel and the other two sides are parallel. So the opposite called opposite side are parallel. Good.
Hmm.
So that's definition. To this and this side are parallel, and this side and this side parallel. So that's the definition. Well, then with the definition, we can figure out their properties. One of that is this side is also congruent to this side. And this side is also congruent to this side. Good.
Mhm.
So basically, the opposite sides are equal and parallel. So that's how we define it. Okay, from that, we got something called a rectangle. Now, rectangle is a special kind of parallelogram. Uh, what made it special is that the angles here, they are all 90 degrees. And that's what rect call the first four words rect come from. Rect come from. Angle, of course, that's the angle. So that means we got four right angles. And this side and this side parallel, this side and this side parallel. And this side is congruent to this side, and this side is congruent to that side, just like the parallelogram. But the special is that their angles, all the internal angles are uh, right angles. Good. So from a parallelogram, we got the special type, which is rectangle. We also have a special type, which is something like this. So all the sides are parallel and all the sides are equal. So these two opposite sides are parallel. This is parallel, and all sides are equal. So equal length. Okay. Do you remember what kind of, how do we call this type, this special shape?
Which one?
This one I just draw.
Oh, a rhombus?
Rhombus. Very good. So a rhombus is special kind parallelogram. What made it special is all sides are equal. So this is called rhombus. Now we have all four sides are the same, and all the angles are 90. And this one is called hello.
Sorry, it's glitching.
Yeah. So we have this, all sides are the same length and all angles are 90 degrees.
Mm-hmm.
So what shape is that?
Rectangle or square?
Where? Now square actually is a special type of rectangle because we have all the angles, internal angles are 90. It's also a special type of rhombus because all the sides are equal length and all the opposite sides are parallel. Good. Okay, now we're going to looking at two more. Okay. Uh, one is this. You only have two sides parallel. And this, do you remember what's the name for that?
Forgot.
Trapezoid.
Oh yeah.
Okay. So just only two sides are parallel. And another one is this shape, kind of like made of two isosceles triangles. This side and this side are the same. Then we have this side and this side are the same. Good. Now, do you remember what do we what name we give to this kind of shape? Hello?
Sorry, kicked me for a second.
Okay. So we got,
What shape is that?
yeah, what's the name for this shape? So this side and this side congruent, and this side and this side congruent. Think about what kind of shape you see in real life.
One second.
Hmm?
1 second.
It's something you fly or
Oh,
fly.
a
We call it kite. Good. So those are the special quadrilaterals we're dealing with.
Oh, okay.
Yeah, we
Yeah.
got parallelogram, we got rectangle, we got square, we got rhombus, we got trapezoid, and we got kite. And so that's normally what we're dealing with. Okay, so those kind of how we define them, and then we're going looking for their properties. Good.
Hmm.
So the first one we're looking at a general shape, general quadrilateral. And we know that they have four sides and they have four vertices and basically the corners they have. And they have, uh, we have two diagonals. Is any shape like that? Two diagonals,
Hmm.
two diagonals. And uh, we have um, very important is when you add all the interior angles together, you'll get 360. So sum of all interior angles is 360. Well, this actually is pretty straightforward because you can cut this into two triangles, right? So you got two triangles. And we know that each triangle interior angles is 180. We got two, so 360. Good? Yeah. So that's very general. Any quadrilaterals have that. Four sides, four vertices, two diagonals. Sum of interior angles is 360, and also four interior angles. Okay. So that's the general property of quadrilaterals. And then we're going to get more specific. Uh, and by the way, there is also another type of quadrilateral, general one. One is called convex. So this is called convex quadrilateral. Another one is called concave. Concave. Concave will have shape of this. This is concave. Good. So it's kind of like a K kind of built into it. And it's kind of indented, kind of pushed inside. Now, what's interesting about concave is that one of them angles has to be bigger than 180, like this one. It's bigger than 180. That's what's special. Another special is when they have one of diagonals is outside of triangle, the shape, like this one. This diagonal is outside of the quadrilateral. But this is fine. This is inside, but one of that is outside. Good. Okay. So now we got going looking at the properties of parallelogram. Parallelogram. And their properties is that, of course, the opposite side are equal in length. Opposite side, we can say are congruent. and also opposite sides are parallel. So it has all the properties of a quadrilateral, then this is just add on. Okay. And also the opposite angles also are congruent. Congruent. And you can see if you have parallelogram, this angle is congruent to this angle, and this angle is congruent to that angle. So opposite angles are congruent. And then we have the adjacent angles are supplementary. Talking about this angle and this angle add together 180 because this and this is parallel, right? And also this and this is parallel. So therefore this angle and this angle add together 180. So that's just from what we learned from parallel lines. Okay. And we have its diagonals. The diagonals actually are bisecting each other. That means each cut them to equal half. So this and this are congruent, and this side and this side are congruent. So that's the diagonals. Diagonals bisect each other. Good. Okay. Lastly, is that the diagonal, each diagonal split the parallelogram. You can write like symbol like that into two congruent triangles. Congruent triangles. Okay, so you can think of this triangle, right? This triangle is congruent to the triangle below. And also this triangle is congruent to this triangle. So basically the diagonals cut the parallelogram into two congruent triangles. Good? Yeah. Okay. Grayson, we good?
Yep.
All right. So now we actually get onto rectangles. So, well, if we know the parallel properties of parallelogram, we pretty much uh, know about those rectangles and squares. Okay. So it's a special time a parallelogram, so it has all the properties of parallelogram. But here's something new. Something new is that all angles are 90. We're talking about interior angles. Angles are 90 degrees. Good? Yeah. Grayson? Okay. And also rectangles, you can see that we definitely cut that into two right triangles. So two right triangles. Okay. And then we look at the rhombus. Rhombus. Well, because rhombus is a special parallelogram, so it has all the properties of parallelogram, and then we have additional. This is called additional properties. This is additional. And same thing here. This is additional. And the rhombus, we know that they have the diagonals. Well, first of all, we know the diagonal is going to bisect each other, but it bisect each other at the right angle at 90 degrees. Good. So when you have a rhombus, you got this, and when you're drawing that, you see that the diagonals actually not only bisect each other, but also forming a 90-degree angle. Good. Yeah, and also this is special for the rhombus is that the diagonals bisect the angle. Diagonals bisect interior angles. Okay, so that means this line cut this two angles equal part, and this line cut this side and that side equal part. Good. Yeah, Grayson, we good? Hello, Grayson. Hello. Hello, Grayson. Yeah, kind of frozen a little bit. Okay, we good for rhombus? Yeah, Grayson, are we good for rhombus? Hello?
Yes.
Okay. All right. So now we're looking at the square. Now, square basically is a special kind of rhombus and rectangle. So you share all their properties, and uh, the only thing additional to that is all four sides are the same, not only parallel to each not only the two opposite sides are parallel, and they are all the four sides are congruent, and the angle are also congruent, 90 degrees. That's kind of special about square. Okay, good.
Good.
Okay, just two more to go. One is trapezoid. Trapezoid is a special quadrilateral, but uh, it only have uh, exactly one pair of parallel sides. Okay, and the other two sides, this is a non-parallel side, it's called the legs. So this is one leg, there's another leg, we got two legs. And this is called the base. We got two bases. And now, if the two sides are equal, this and equal to that, we call it isosceles trapezoid. And for isosceles trapezoid, then the two base angles are the same. Okay. So base angles are congruent. All right. Um, so the diagonals may or may not be the same. Okay. If it's isosceles trapezoid, then the diagonals are congruent. But if it's not, then it's not. Okay, so that's trapdoor. Okay, then lastly is the kite. So, and well, we know the kite shape is like that, kind of special, like that. And now we know the properties. The properties that uh, only one pair of angle are congruent. So these two are congruent. But the other two are not. Like this and this side, they are not. So we got one pair of opposite angles are congruent. And we can write like that. This is the symbol for that. And they do have a diagonals go like this, and the diagonals, one of them bisect, only this. So this longer one bisect the shorter one, but the shorter one does not bisect the longer one. So we said, and so we said one diagonal bisects the other, but we only have one. And we know that the two diagonals, they intersect at the right angle. Two diagonal intercept. I'll send you today's lesson. So they list out all the properties. So you have a reference. Intercept at 90 degrees. And the last one is we have one diagonal. One diagonal is the axis of symmetry. So that means in this case, this is the axis symmetry because this side is congruent to this side. So you can think about this is just cut this in equal half. Okay, good. So now a square actually is a special kind of kite. You can see that the square can come from a special kind of rectangle or special kind of rhombus, and it's also special kind of kite. Good. So now we're going to just going over some problems, practice, and you tell me based on what you learned, what would you the answer? Let me see if I can just copy paste that. Copy. I cannot do that. Okay. Well, I'll just show you the questions. Okay. Let me share that. So get out of here. And I'm going to share the screen. Okay. So the first one, a shape has four equal sides and all angles are right angles. What type of quadrilateral is it? Think about that. Four equal sides and all angles are right. What type of quadrilateral is it? Okay. Yep, very good. Problem 2, true or false? All rectangles are squares. Yeah, I just give true and false. Yep. Only square. A square is special type of rectangle. Okay, a quadrilateral has three angles measured. One is 95 degrees, one is 85. The other one is 110. So what is the fourth angle? So remember, when we add all the interior angle together, that equals to a fixed value. Yep, very good. We'll skip the area. We haven't done the area yet. Next time. Okay. A quadrilateral. Hmm? A quadrilateral has one pair of parallel sides and legs of equal length. The base angles are also equal. Name the quadrilateral. Well, no, we are doing this, okay? Good. So a quadrilateral has one pair of parallel sides and legs of equal length. The base angles are also equal and name the quadrilateral. No, it's not rhombus. Rhombus has two pairs. So rhombus is like that, two pairs. But here we only have one pair of parallel side, and we have legs, two legs.
I forget what it's called, but I know what it looks like.
Okay, that's called trapezoid. Good. Kind of like a trap door, but it's trapezoid. Okay. And what type of trapezoid? Because this is a special type of trapezoid. This side and this side are congruent, and this angle, base angle, and this angle is congruent. So what kind of special trapezoid is that? So that's called isosceles trapezoid, just like isosceles triangle. So it's isosceles trapezoid. Isosceles triangles, two legs are the same. Isosceles trapezoid is also the two legs are the same. Good. Very good. Let's move on to number 7. Uh, a quadrilateral has both pairs of opposite sides equal, diagonals bisect each other, and all angles is 90 degrees. Sorry, this is kind of messed up, 90 degrees. So that means both pairs. So this and this side is the same, and the other side is the same. And the diagonals bisect each other. So we got here and here, they bisect each other. This and this. this side equal to that side, this side equal to that side. Good. And the all angles are 90. So we know this is 90, this is 90, this is 90, this is 90. So they want us to prove it's rectangle. Think about what missing from the definition of a rectangle. That's part. The missing part is what we need to prove. Okay, well, first of all, we know this side and congruent that side, and this side and congruent that side. So that satisfies part of the definition, because definition of rectangle is that the the opposite side are congruent. So we meet that definition. And but also said this side and this side are parallel, and this side and this side parallel. Well, how do we prove this side and this side parallel? Well, you're looking at here, basically this line here, if you extend it out, is, and we extend out this line, and this line is the transversal of the two lines. And this side and this side we call consecutive interior angles. And they are supplementary. So therefore, this side and this side are parallel. Similarly, we can prove using this one as the transversal, and those two lines here, this side and this side are consecutive interior angles, and they are supplementary. So therefore, this side is going to congruent to that side. So then by definition, this is a rectangle. Good?
You're going to get a bag of candy? So we're going
Yeah, so we can see that when we're trying to prove something, we just prove the missing part, okay? Some part is given, like these two sides are congruent, and these two sides are congruent, and we know the angle 90, 90, and 90. So what's missing is the parallel part of it, so we had to prove that. Okay. And number 8, find the parameter of a square with diagonal length of 10. So we know this is 10. We want to find the parameters of that. Do you guys remember 45, 45, 90 special triangle? Do you remember that? Okay. Well, 45, 45 special triangle tell us this. This is a 1, this is a 1, this side is square root 2. Now we know this side is the same. So this is going to be this angle and that angle have to be congruent. We know this angle is 90. So this one is 45, this is 45. So exactly this, which means that one side that means 10 is s times square root 2. Good, because this side over this side is square root 2. So 10 over s, it's basically is 10 over s is equal to square root 2 over 1. So 10 is square s 2 over s, which s is 10 over square root 2. And then we can times square root 2 on top and bottom. And we got 2 on the bottom, we got 10, we got square root 2, which is 5 square root 2. That's just one side. We got 4 of those for the parameter. So the parameter is 4 times s. Then that gave us 20 square root 2. Good? Yeah. Grayson? Hello? Okay. Now we're going to looking at number 9. We got 2 more to go. Number 9 is in a parallelogram, one angle is 70. What are the measures of other 3 angles? Think about, we got parallelogram.
You tell me you were a super mega ultra lightning babe. That's all right.
This is 70. Okay, we want to figure out the other 3 angles. Good. So let's call this A, B, C, D. So our D is 70 degrees. What is angle A? What is angle B? What's angle C? Good. Yeah, Grayson, you good on that? Very good. Yeah. So we know D is 70, then opposite has to be congruent, which has to be 70. And we also know that this and this add together has to be 180 because this line and this line parallel. So it's 110. Very good. Okay. A quadrilateral has one interior angle equal to 210 degrees. So it's asking, is it convex or concave? And ask us to explain. Yeah, it's CON, con, cave, cave like cave, the place you hide in. Yeah, this is concave because we got something like this. This side is more than 180. That's a concave. Convex, and any sides won't be bigger than, won't be always less than 180 for the convex. But for concave, then one of that is this one. This one is always bigger than 180. Yeah, otherwise, if this here, then we got a triangle, and this is 180. If we push out, we got concave, convex, and this side will be less than, this will be less than 180. And here it's bigger than 180. Okay, very good. So that's what we have for today, okay? I'll send out some homeworks for you guys to do. Good? Yeah. Grayson, are we good? Hello, Grayson?